Welcome everyone to the Powerchain webinar, and I'm joined today with Ivan Carter, who is the Technology Manager at Selectronic here. So I'm coming to you from my off-grid isolation in southeast, well, sort of southeast Melbourne, and Ivan's coming to you from his hybrid-powered home just north of Melbourne. Would you describe that as Ivan?
Yeah, probably more northeast of Melbourne, on the fringe of the Melbourne growth sector. So yes, can dodge around a bit of the traffic, but yes, certainly not as remote as Lindsay.
So we are practicing our social distancing as we're supposed to, but thankfully that is starting to come towards an end. So hope you've been coping with the isolation situation well, and it hasn't brought too much grief to you or your family. As with any presentation, there've always got to be housekeeping, of course. So if you do need the toilet, I don't really know where you need to go. I know that I would go out of the study here, turn left past the kitchen, go through the sliding door, turn right past the cat tray, and then I'm there. But for you, well, maybe it's just ask your wife, something like that. Hey, if you also hear a whoop, 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 one of those sounds, then we are going to, you have to ask your wife again, basically, where to go, because I can't help you. So what are we here for? Well, there's this wonderful new release called Powerchain. We want to spend the next hour just taking you through just simply the Powerchain. We can cover lots and lots of subjects in some of our training, but this one is just focusing on the Powerchain system. So as John said earlier on, please just send any questions through the Q&A section rather than the chat section. So what is Powerchain? Something that's been in the 18 months in the making, and it is simply the linking of multiple SP Pro bidirectional inverters, battery-based inverters, of course. So whether that be a single phase system, whether it be a dual phase system or a three-phase, doesn't really matter. Powerchain can handle all of those. Whether that be off-grid or on-grid, again, doesn't really matter. We're talking about the linking of multiple SP Pro battery-based inverters. So those of you who are familiar with what we've been able to do in the past or up to now, you might recognize this as the three-phase system that we've been able to deploy with you. 3 SP Pros, one on each phase, creating a proper 120-degree separated three-phase output with some three-phase grid inverters. But now, thanks to Powerchain, we've got the ability to expand that system by groups of 3, right up to a maximum of 4 inverters per phase. And then it gives us the ability to start increasing our PV capacity as well. By adding 40 kilowatt select sun units on, we can now handle up to a maximum of 480 kilowatts of managed AC coupling PV. So it significantly enhances the size of systems that we can actually now provide to you in this market space. What about if we're doing a single phase? Then we've got the ability, as I said, with 4 SP Pros, up to 4 SP Pros per phase. And that could be talking to up to 5 Selectronic certified inverters, like we have here with the example where we're using the Fronius Selectronic certified inverter. If we were to use those Fronius, if we were going, say, with a 24-volt system, 4 of our 24-volt 4.5 kilowatt units, we could have up to 18 kilowatts of continuous power. And please keep in mind that when Selectronic talk power, we talk continuous power. We don't talk short-term ratings, it's continuous power. That would allow us up to 5 of the, say, 8.2 kilowatt Fronius, but we have a limit again of 2 to 1, just like you've been used to with the ratios of 2 to 1 for managed SP Pro, managed AC coupling, I should say. And effectively, so for every kilowatt of SP Pro you can have 2 kilowatts of S-Cert or Selectronic certified PV inverters. So up to 18 kilowatts and 36 kilowatts of managed PV. If it's a 48-volt system, 4 of the 7.5 kilowatt units would give us 30 kilowatts, and up to 41 kilowatts of managed PV, because that's the maximum 5 times the 8.2 Fronius S-Certs. If we're going to go with the 120-volt systems, we can use 4 of our 20 kilowatt SP Pros and up to 41 kilowatts managed PV. Again, the limitation there just simply being the 5 times 8.2 Fronius. What if we were using ABBs in exactly the same kind of situation? then all the numbers there would be the same, excepting the biggest ABB being a 6 kilowatts, so 5 times 6 being 30 kilowatts. So whether it be a 24 volt system, 48 volt or 120, the 30 kilowatts becomes our maximum managed PV. Starting to show some of the flexibility that we've got now, though, is that we can actually have, on a multi-phase system, we can have different types of Selectronic certified. So in this example here, where we have a dual phase system or a split phase system, we can have ABB being on one phase and we can have Fronius on another phase. So we're starting to see Powerchain really bring in some added flexibility to something that we think has already been pretty flexible. With a three-phase system, again, we can do the same thing where we can have all Fronius on from one system or one manager, as we call it, and Ivan will go through that in more detail, and select suns on the other. So we might have a situation of you've got a lot of shading in a particular area and we need to use the dual MPPT abilities of the Fronius. That's where we'd use the Fronius, but just for some sheer grunt and some extra power, we'd use the select sun, which is, say, their bigger one, which is the 40 kilowatt. So we've got that ability now to have different languages, if you like, split throughout the system.
So Lindsay, a question's just popped up about DC coupling as well. So the question is, we can use AC coupling with the Powerchain. What about DC coupling? Can we use that as well? That's from Paul Rodden. Thank you.
Thanks for the question, Paul. Hope you're well. Yeah, anything that you've come to know and love about SP Pros, effectively just think of it as it's just the same, but it just got bigger. So yes, absolutely, DC coupling can be used just like it could be used in the previous smaller systems. So there's the same limitations apply. Ivan will cover that in a little bit more detail later on, but the simple answer there is absolutely yes, we can handle DC and AC coupling. Thanks for that question, Paul and Ivan. Powerchain will use the common battery bank. So when you're talking about multiple phase systems, it allows us to be able to take energy that might be excess of PV on one phase and be using that on the other phase, which might be having a shortage of PV. So it's a common battery bank amongst all of the SP Pro inverters. We just wanted to give you a little bit of background, however, on just the testing and how far we've gone to try and make sure that this is a robust and well thought through type of a solution. So a couple of little happy snaps here before we get into some of the more technical understanding of the system from Ivan. So this is Orpheus Island up in Queensland. This was installed in March 2019. So yes, that's not a misprint. It's not meant to be March 2020. It is March 2019. Done by our mates at Platypus Power. Orpheus Island has 20 kilowatt SP Pros on there, 9 of those, and 360 kilowatts worth of Select Sun PV inverters. And that's been running the resort now for 13, 14 months. Sure, along the way, it's had some things we've learned, but we certainly haven't had any situations such as outages or major catastrophes. That's a view inside the inverter room there, where you're seeing just that. Very neat installation. A couple of things we might have just done a little differently in hindsight there, but in general, it's come up as a very, very nice system. Here's another one in Wanjuro Station in outback Queensland, done by Tropical Energy Systems. This is in a container where they were using a single phase system, 3 7.5 SP Pros and some Fronius. Quite interesting the way that Adam Wilson from Tropical Energy Systems did this. He actually split the container in half so that all his cabling, etc., is in the other half that you can't see. And this way, where the heat is actually being generated with the inverters, then that's what he has to actually thermally control. So it takes the load off that thermal air conditioning quite nicely. There's the view from the other end. The batteries are down the far end there. Fronius in the foreground. Quite a neat system. And there's another shot there just from the far end inside the containers. Some Gen Z lithium batteries were used on this one. I should point out on the previous slide, Orpheus Island, they used some BAE lead acid batteries. I think the battery capacity on that one, correct me if I'm wrong, Ivan, was something like about 6,000 ampere hours at 120 volt. Can you recall exactly, Ivan?
It was actually 13,000 amp hours at 120.
13,000. That's, I think, 4,000s in parallel, was it? 3 or 4 of those. So a lot of energy on that battery bank system. And here's another one done by Select Energy not too long ago. This was 6 20 kilowatt SP Pros, so 120 kilowatts continuous power, and a couple of the 40 kilowatt Select Suns and some 20 kilowatt Select Suns. So you guys do tend to get to work in some very, very nice places. There's the install with some very nice ducting work done underneath the inverters there for all the cabling and isolators. And another view showing the Select Sun inverters on the right-hand side, SP Pros on the left-hand side. Again, this job used BAE lead acid batteries. And Ive, can you recall the exact capacity of that one? I don't recall.
This one was a similar size. I think it was a little bit larger though, but in that same sort of order.
Yeah, and interesting to note, I think, that both the Platypus Power job with Orpheus and this one with Peter King and his team chose to use lead acid batteries. And so I think it's a good decision to be saying horses for courses there.
Yeah.
And I'd just love to...
Peter King has just popped in. So Peter King's joining us on this webinar. That's him in the middle on your screen. He's just popped in with 2.2 megawatt hours at C20 is installed on Badara Island. So thank you, Peter.
Wonderful, Peter. Thank you for that clarification. 2.2 megawatt hours. So that's a nice little battery size to be handling. And I thought it was appropriate. And I think obviously Peter hasn't seen this picture, but I thought it was appropriate to put this in. Nothing like the installers deciding to put up a bit of a solar selfie. And when one is wearing a Selectronic cap, well, that's just got to get a gig. So yeah, well done, guys there. And they were pretty happy to be part of such a great system. So these were part of what we called our pre-release systems, where we used those systems after we had done all our own testing. So the way that Selectronic works all that is that obviously our work gets done in the lab and they try to break things in the lab, but you'll never get all of the cases, the real world cases, in a lab. So after that, then they go out to our own sites, which is people like myself, Ivan, our CEO, our production managers. We all have systems. They go out to those. Then once we get to that stage complete and we're happy, then they go out to some of these pre-release sites. So thanks to everyone who was involved in that. I'm going to hand over now to Ivan, who's just going to give you a little bit.
Before you do though, Lindsay, there was one other question that came in that I was just holding off for you. So the question from Colin Croft has come in. Can you link different power inverters together? So I'm assuming Colin means different SP Pro sizes on that one.
So if you're talking about SP Pros, again, we'll cover that in just a moment, but no, they all have to be the same model. If you are talking about the grid inverters, as long as they are the same brand on the same, we'll call it the same phase to keep it simple at the moment, but they can be different power levels. But the SP Pros can't be different power levels. They do need to be the same model. So thanks for that question, Colin. If we haven't answered a question completely, feel free just to add a bit more on your Q&A, just say, but I meant this or that, because we get a quick snapshot of your question. So sometime we may or may not totally understand it. So I'm going to throw over to Ivan now, just to go through a little bit more of the technical and install side of things. So take it away there, Ivan.
Okay, so thanks, Lindsay. Thanks for that good summary. And I must thank Peter for just popping the answer in for us. Thanks for that. But yeah, certainly moving on to the SP Pros, I want to talk about the system and how you can use it and how the system in a general way works. First and most important thing is that all SP Pros evenly share the load power or the charging. And it's really quite important that it do that. It means that they're all working at the same way, they're all running at similar temperatures, and they're all providing their energy dynamically and all at the same time as loads switch on and off. And the reason that's important is that it gives you really good stability. You don't see any light flicker or anything. You can imagine if an inverter ramped to its full capacity, started to struggle, and then the next one came on to take over, you get all sorts of flicker and instability through that point. So with the SP Pro system, they all evenly share both load and charge power for the system. Moving on, and then of course I've said that, so what do I mean? What I actually mean is that the continuous power is you simply add them together. So in the example, you've got the 20 kilowatt SPLCs. They're a 20 kilowatt continuous output, as Lindsay said. You've got 2 of them. You've got 40 kilowatts of continuous power. And again, like with the output power, the same. The charging currents are simply added together. So you can simply go, right, I've got 1 of these, I've got 2 of them, I get double everything that you would expect. And as he mentioned earlier, it's all 24/7 continuous powers, not the 30-minute short-term powers. But when we're talking about those short-term powers, they're added together as well. So you're truly getting a combined system that adds it all together in every single way. Moving on, please. Yes.
Sorry.
Now we've got to try and coordinate who changes the slide and who's saying what. So if it's a bit slow at times, you can just make sure, send some comments to Lindsay. He's a bit slow on his mouse, but we'll get there. Now, as the question was before, all SP Pros must be the same model. You cannot mix and match. You have to have if you've got an existing 481 and you need to go to, you need a bit more power and you're thinking, oh, maybe I can add the 480, the 3.5 kilowatt. No, you have to add another 481. So it's a 5 kilowatt with a 5 kilowatt. And that's the same across all the models. As was asked earlier, DC coupled, AC coupled PV systems all work in exactly the same way. We simply, for AC coupled, when it's managed, it's twice the AC output. If it was an unmanaged AC coupled system, it's the same 1-to-1 ratio that we've always worked with. And certainly with the DC coupled, as long as you can couple the DC in with a shunt to the system, exactly as if you were running a single system, then the DC coupling works in exactly the same way. And of course, a common battery bank for the reasons that if we didn't have a common battery bank, the DC coupling wouldn't work appropriately. But the most important reason is you get that good sharing of power between phases. And that's particularly important when it comes to 3-phase systems. In the case of an off-grid system, with the SP Pros working balancing across the battery bank, we can actually make sure that despite the loads that might be all over the place and unbalanced, the SP Pro can present an even balanced load to the generator to keep it running happily, and it wouldn't be able to do that if it couldn't share its power between the battery bank. And of course, that also applies to grid systems where utilities want to ensure that you feed evenly out on your grid supply. Again, doesn't matter what's happening on the load side, the SP Pro can do all that balancing for you, and you can only do that because of the common battery bank.
Before we move on from battery banks there, Ivan, Romy's asked us the question about, do we have any experience with flow batteries? I'd like to cover that part.
With flow batteries, so we do have some experience with flow batteries, but what experience we have there would be the same whether it's a Powerchain system or a single system. The key with flow batteries is really working on the integration of the two between each other and making sure that the operating modes of the flow batteries are compatible with providing continuous power depending on how they need to operate. So yes, certainly works with flow batteries.
I think if I could just add in there, please, Ive, there are of course some flow batteries which need to shed their plates regularly. And if you have 0 voltage coming out of a battery bank, we haven't worked out how to actually invert that into 240 volts then. So that does create a little bit of an issue to have to deal with.
Yep, thanks for that, Lindsay. And it's suitable for any Series 2 SP Pro with an advanced comms card. So the Series 2Is that are shipping now, they're ready with everything you need for Powerchain. If you have a Series 2 that's got an advanced comms card, that's ready for Powerchain. If you have a Series 2 with the original comms card, simply by adding the advanced comms card to it, and you can be ready to go with Powerchain. And given that, because the system does require a comms cards don't go into the Series 1 unit, so unfortunately not suitable for any Series 1 at all. And whilst we've always tried our very best to maintain backward compatibility, the CAICO inverters have finally been dropped out of the software. They're still supported right up to our very latest release, just not the Powerchain release. So not suitable for Series 1 or with CAICO grid tie inverters. So what do I need to consider when I'm going to install one of these systems? So the Powerchain system, each SP Pro has to be interconnected by the built-in sync system, which is a method of allowing the units to all communicate and manage the power flows as I've described earlier. Firmware version 14, so that's of course our Powerchain release. So any unit that's applicable for becoming Powerchain, download and install the latest software, update to version 14, and you will be Powerchain ready. For monitoring, and we'll cover it off a little bit further later, but you only need one Select Live. One Select Live can monitor obviously a single system, but one Select Live could also monitor our larger system, which would be with the 12 SP Pros on a 3-phase system. So you only need one Select Live for monitoring. You may also need, with the system, and we do cover in further on slides, you may need an external contactor where previously you may not have thought you needed one, but we'll go into some details about that. But external contactors need to start coming into these designs.
Just before we go on there, Ivan, just got a couple of questions. So Alice there is asking us about having an older model coupled to a new one of the same type. Do you want to maybe just clarify that one for us?
Yep, so an older model, so as long as it's a Series 2, it will be compatible with software update and Powerchain. So any of the Series 2s, it may need to have an advanced comms card put in it, but as long as it's a Series 2, you can bring it up to make it Powerchain compatible. You still have to remember with the original Series 2s, the first lot only worked with Fronius, grid tie inverters. You needed the later version or Rev 21 to work with ABB, but yeah, any of the old Series 2s can be made to be compatible with Powerchain.
And we've got a couple of similar questions from Paul again, and also from Tim Webber. Good to hear from the West, Tim. But just talk about the size batteries that might be required on some of the systems that we've shown so far, where the question is it going to be multiple batteries or is it going to be parallel battery strings? And Paul's suggesting, as we have often said in the past, multiple parallel strings, aren't they a bit of a no-no with batteries? And Tim's asking sort of basically the same question, but if you are having a multiple battery system, then what do you do for multiple battery monitoring or metering, such as string monitoring of each battery, or perhaps midpoints, that style of things? Maybe we can roll that one into one answer.
No worries. Certainly parallel battery banks have always been a consideration to ensure that when you're pushing charge power into them and when you're pulling power from them, that they work evenly. Nothing has changed there. It's interesting with the advent of small lithium modules that we're now seeing that happen far more often, where lots of little lithium modules are put together and they're all effectively running in parallel. So there's some parallels, no pun intended, parallels there. The key, of course, is where the batteries come down to the common battery connection point. Through testing, that you make sure that they all charge evenly. At the moment, the SP Pro system still only monitors from one point, so we can't monitor through the midpoints multiple mids of all of the strings, but it really comes down to ensuring that through the commissioning process that everything is working correctly. The other point is with the Powerchain system, because all of the inverters work evenly, you can be sure that regardless of your cabling distances on your DC, that all of them will push an even amount of power, and that's because we've got our comms loop. So whilst it's good best practice to minimize cable length, you don't have to ensure all of the DC cables from each of the SP Pros to that common battery point are the same length, because the comm system, our sync system around the outside of that, ensures everything works evenly. So hopefully I've covered that off for you. Now with Powerchain, we've introduced some new terminology, and the first one we need to, and you'll see written everywhere, is our system manager. It's responsible not only for doing the normal inverter functions, but it's also responsible for telling everyone else, all the other inverters, what to do. So it's got quite a job. You know, if we're going to a multi-phase system, you will also have phase managers. They're responsible for their own phase, and then when we add multiple devices to the same phase, you can see on the slide there, they're all referred to as workers, and those terms will be used all through SP-Link, so it's good to get to handle on what all those new terms are. So the system manager is responsible for the whole site. It's the one that you connect SP-Link to, connect your laptop to, connect Select Live to, and do all of the configuration of the system. You only ever need to look at the system manager. There's also quite a change with Powerchain from those who are used to you running our original three-phase system called Advanced Multi-Phase. Only the battery lights and the battery charging lights now operate on the system manager, so that's the main focus of attention. The lights on all the other units will simply show the inverter mode and any of the alarm lights that are relevant to that unit. So that's quite a change from the original three-phase system.
Ivan, why not just use master and slave like we've all got used to?
Why not use master and slave? Because master and slave, we're progressing, we're moving on. We don't have that anymore. And whilst people may think that it is a bit pedantic and a bit politically correct, you'll find that some people, particularly through Africa, will be quite offended by those terms. So we chose to use different terms. You know, being a global company, we need to be globally responsible, and using terminologies that don't offend, I think, is only a good thing. So moving on, we've got, so what I'm going to start taking you through now is how do we connect up this worker unit that we're putting on. I can hear Labor people complaining workers are suppressed and all that sort of stuff. But anyway, I digress. So the Manager SP Pro is connected up in exactly the same way, whether it's the grid or the generator. The power feeds the AC source through the SP Pro and out the AC load terminal. Any worker is only connected on the AC load side. Now the AC load side, you may have recalled that's only the output side. Well, in fact, it's been turned around and it now can draw power in to push into the battery bank as well as what it's always been able to do is push power out to feed on the loads. So when the generator or the grid is running, if it's charging, it pulls power in through its AC load connection and pushes it into the battery. So all of that current that the worker and the manager itself, not to mention the load, all comes through the manager's AC source contactor. And that source contactor has a limit of 63 amps. So what does that mean for Powerchain systems? If we move to the next slide, if the site load and the worker combined can exceed the capacity of the contactor within the manager SP Pro, then you'll need to put an external contactor on. If it doesn't exceed that, then you don't need an external contactor in single phase systems. So you can see here on the next slide where we've got 3 inverters here, where we've got an external contactor wired in. So you can see the difference here with external contactor, and for those who have used them, it's exactly the same as you've done before. The external contactor is controlled by the manager, and then all of the AC load sides are hooked up to that. So you can see an external contactor is required if the draw through the internal is greater than 63 amps, if it's one of our SPMC models, or if it's greater than 125 amps if you're using one of our SPLC models.
So in that example then, Ivan, are you suggesting that if these were 3 of the SPMC 480s, which is the 3.5 kilowatt 48 volt, you may not need an external contactor?
That's exactly right. As long as the draw doesn't exceed the 63 amps of the internal contactor, then you don't require one. Now moving on to 3-phase, this is where it gets a little bit different. If you, in this case with the all of the managers in place, you would use the normal rules. Only need an external contactor if the AC current draw is going to be greater than each of the manager's internal contactors. But as soon as we add a worker to that system, regardless of whether the currents are going to exceed the internal contactors, we definitely need to put on an external contactor. So think of it in terms of if I've got multi-phase system and workers, I must have an external contactor. Moving on, so now all of the other diagrams had shown some, really high level diagrams. This diagram is quite detailed, but it's detailed for a good reason. There's a couple of things that we need to really point out. So it shows the external contactor and it's controlled by the system manager only. And this arrangement shows there's an CT that measures the currents and so on. But the most important point to see in this is you'll note that the active and the neutral wires coming from the managers and from the workers are drawn together. And they're drawn together because they must run together. And that's to ensure that we don't get any resonance in those cables and have instability in the system. So that's a key point from this slide is your actives and neutrals must run parallel together before where they go and join up. From a DC wiring point of view, it's very much the same. Whilst this diagram shows the battery positives and the battery negatives going in all sorts of different directions, this is really only a schematic for clarity, but all workers and managers must be connected clearly to the battery system. And it is certainly very good practice to ensure the battery positive cables and the battery negative cables run together and aren't separated as shown. Well, it's a schematic, but that's how you should run those things. You will note that there's there's one battery temperature sensor that goes through to the manager. And if we go to the next slide, you'll see the monitoring. Oops, we must have that slide. If you just go back one, please. Sorry, Lindsay. The DC wiring, there's also if you go to the DC wiring, please, you'll see you will also need to connect up your pre-charge wiring and the midpoint wiring. The pre-charge wiring goes to all units, because clearly all of them have capacitors in them that need to pre-charge. There's no change there. And if you're monitoring the midpoint of the battery, then that connects to the system manager midpoint connection. Moving on, please. We talked earlier about the SP PRO Sync bus. So this is a daisy chain arrangement which connects all inverters together. You can see in the diagram how that all connects up. It's very straightforward. You can connect the sync in any order. The key thing to remember is you must have the termination plug, the little black plugs in the picture there, at the start of the bus and at the end of the bus. And yeah, that's the key thing. And all of those bits are provided in every inverter. So once all you guys have installed 20 systems each, you'll end up with 40 leftover sync plugs as termination plugs, because one's provided with every unit. So we'll move on.
Just a couple of questions there whilst we're on the communications and general failure there. One from Jeff. If the system manager fails, do the two-phase managers also stop working? And sort of coupling into that a little bit with another question from Paul. If the manager falls over, does another unit or phase manager automatically take over and work a setup? And maybe you could answer that one for us, please, mate.
No worries. So I'll go through it in all of the scenarios where there might be a failure. And I'll start with the workers. If a worker drops out for any reason, then it drops out. The system manager knows about it, and it reduces the power on that phase appropriately, calculating for the loss of that worker. The worker, if it's able to restart or connect back into the system, it will then restart and resync back into the system automatically when the grid supply or when the generator supply comes in and is allowed to do so. If a phase manager happens to drop offline, then that does bring the whole system down. And the reason is if a phase manager drops out of the communication system, it no longer knows what phase angle to run at in relation to the other two phases. Without having that information, well, that could cause all sorts of problems for three-phase loads. You could imagine a motor trying to spin when one of the phase angles drifted out to 170 degrees or something like that. It wouldn't end well. So for that reason, if a phase manager drops out, the site will drop. And again, if a system manager drops out, no one knows what's going on in terms of the SP pros. And so the system will shut down in that case. Now, configuring a system. So configuring a system, we have really worked hard to make sure that the system operates and feels like just one system. So you saw before where the system manager connects to and configures everything. Well, it's the same with SP Link. SP Link talks to the system manager and configures the whole lot. So it really is just one big system. The site configuration wizard, which I hope you all use and appreciate the efforts that's gone into there, has just been adapted to suit the Powerchain systems. And the difference is you simply tell it, it's a power chain system and how many inverters I'm having per phase. And otherwise, the site configuration wizard is exactly the same. So once you've run through the site configuration wizard, the final step that you have to take is you actually have to tell each inverter what its role is in the system. And the image on the screen there is from SP-Link, and you drag and drop each serial number across into its position, store those assignments, and then they're locked in. Really important to do that and get that correct. You don't want something that's physically wired to L3 being told it's an L2. Again, you've got all those phase angle issues. But we've put a little smart in there, so if you click on one of the serial numbers, the unit will flash at you so you can verify, yes, I'm assigning that unit, which I know I have wired to L2, and I'm assigning it into L2. So that's a nice little feature there. But that's it really for configuring a system, large or small. Run through the wizard, tell it what size it is, and then assign the units into the system. And finally, everything I've gone through there is fully documented in our installation notes, which are available on our website. That's a really complicated web link, so you'll get a copy of these slides, but probably easiest, just jump on our website, look under the support tab or under the installation notes section against SP Pro, and you'll find installation note 57. All the details and more are in there.
Thank you, Ivan. Just hoping that that gives you a little bit better of an understanding of the more technical side of things. What we've shown you so far, though, has predominantly been larger systems, and we get this conversation happening very regularly in our office or wherever our office is these days. But the system suggests that perhaps the generator is running too often because the loads have gone up. Why have the loads gone up? It's a fairly common question. And what we find is that in an off-grid system particularly, if you've designed a really good system, then it starts to get more and more overloaded. Why? Because people don't care. They just want to live their life. So they keep plugging things in because your system just handles it, and they keep plugging in, and eventually the system starts to get a little bit stressed. So we might hear the complaint that, wow, the generator's running a lot more than it used to be. Okay, well, I'm going to have to put some more PV in perhaps because it's not able to keep up because the loads have increased. And perhaps our batteries are being stressed that little bit more because the system is being worked much, much harder. So what we can now do with Powerchain is we can simply add in a second SP Pro now to be able to help that system along. We just increased our battery charging capacity, whether that be from the generator, whether that be from the AC coupled PV, but we've doubled our capacity to do so. And we can also now add that extra PV. So remembering when we have a managed system, and I haven't drawn the little communications wires there between the Pro and the Selectronic certified, but just imagine that they are there. So we can get more PV because we can have 2-to-1 ratio between the PV output, the AC inverter output, and also the SP Pro. So for every kilowatt of SP Pro you've got installed, you can have 2 kilowatts of Selectronic certified AC coupling. And I had this conversation just only about an hour before we started this afternoon, where the customer, the installer, wanted to increase the size of the system, and to do so, he was going to exceed the 2-to-1 ratio that I've spoken about. And so the answer to fix that was going to be adding a second SP Pro. I'll harp on a little bit of an example here, though. Whilst we have this 2-to-1 ratio, you've still got to remember, well, yes, the system can handle that, but let's say you've got 15 kilowatts of AC coupled PV on one 7.5 kilowatt SP Pro. Unless you're self-consuming 7.5 kilowatts of PV, then you're going to be wasting PV. So if I give you an example, 15 kilowatts is coming out, we've got 2 kilowatts of load, so we've got 13 kilowatts of unused PV. You have a 7.5 kilowatt battery charger called the SP Pro, you've still got some PV that's potentially going to be wasted. So to take most advantage of that, either increase your daytime loads, or you can add that second SP Pro in. And whilst you're upgrading that SP Pro, it may have been a slightly older Series 2, but an older one, then adding the advanced communications card in to allow it to operate with Powerchain will also give you the ability then to get the CAN bus communications. And if you are going to update the batteries, then you've got opened up that new opportunities, whether it be BYDs or Pylon Techs, LG Chem, Sonnenschein, whatever. We can now handle all that as well. So we've got the ability to add on to existing systems. One thing that we see is really important. We don't want to be putting people into technology corners. We can see some problems coming in the future with that, where people are in a technology corner. But if we take this system that we're looking at right here, when the batteries wear out, which we know will happen, they have to wear out eventually, then we don't want to be throwing all the inverters out because they're all in one cute little sexy box or something. We're just going to replace the inverter. So if we're just going to replace the batteries, small slip, and maybe update firmware in the inverters, and that's it, we keep going. Love the question that we've been getting lately where people are saying, oh, I just went to a site and wow, the inverter's 10 years old. And we sort of go, yeah. So, okay, so yeah, it's just got out of warranty, yep. But people are almost accepting, we're a little bit desensitized to accepting that batteries should last maybe only 5 or 7 years, and inverters should last the same. It doesn't need to be that way at all, not at all. So as it was mentioned earlier on, even though we might have this wonderful, nice, big maximum capacity system that we've got here, we still only need to have one of our Select Live units installed for our monitoring. It will look at the complete system from the data that's given to it by the system manager on our one there, and then you'll be able to see the system on our Select Live portal. Hopefully you've seen what we can now do, that once you've got a Select Live installed, you can get access using SP Link once you've got that Select Live installed. So we're just using that Select Live like a communications gateway, if you like, or a hub to get into the inverter. So no longer do you have to drive to the site to make a change because you might not have done something right, or you think you just need to tweak something, generator starting too soon, too late, whatever. Do that from wherever you've got the internet. Mindful, we don't want to be taking up all of your night. We tried to keep the timing here to suit as many people as we could. We did the first one about 4 o'clock, the next one about 12 o'clock. And my apologies if a cat jumps on my keyboard in a second. Nice pussy. So let's have a quick summary here. These systems now with Powerchain are going to allow us to go up to 240 kilowatts of continuous power. And we've stressed a couple of times now, continuous power. If we're using all 40 kilowatt Select Suns, we've got up to 480 kilowatts of managed PV, so nearly half a megawatt there. And we can expand any Series 2 system, existing Series 2 system. I think the guys have done a wonderful job of making this easy to install. About 3 years ago, Selectronic sort of embarked on a, yes, we do so much, that's great, but we're hearing the stories that, geez, it's complicated. And through our wizard, I think we've done a fairly good job, and we're happy to hear comments about that, but we think we've done a good job in making it simpler to install. And so when you just basically, whether it be one inverter or 12 inverters, there's not that much difference, as I've outlined before. It's using that wizard, answering half a dozen questions or a dozen questions, and it's populating everything for you. And when you bring a managed battery into that, you don't even have to be putting in all the charging parameters for the battery, because it would be pre-populated. We have got a few other batteries coming online next month. There will be the Power Plus battery, will be what we call a supported battery. So it'll be in the wizard. It won't have communications, but it will be supported, pre-populated fields. Also I believe the Sagasa battery, and also the Murata 48 volt batteries are all coming into our system later next month as well. The easy single point configuration, probably already answered that, but it really does simplify things up. So please don't be daunted by the size of what we've shown you here. It's not that way at all. And you'll find that there's no external hubs, and I'm trying to avoid the C word, those other cluster things. We don't have any of that. It's all within the inverters as well. So effectively, Powerchain is built into every SP Pro Series 2i inverter. And to turn a Series 2 into a 2i, just upgrade that communications card. I think they're costing around about $300, something like that. So we've got 10 minutes left. We deliberately wanted to make sure we came within our time. So we've got some questions there that I can see. Ive, do you want to start ripping them off, and we'll answer them?
There's a few questions that have come in. So yeah, so some of the questions come in. So Peter McKernan has asked, and I'll take this one, Lindsay. Peter McKernan has asked, if he's running pre-charge on 12 inverters, what rating should I put on the breaker and cables? I imagine there'll be a fair inrush. Well, Peter, the inrush is simply 12 times the inrush on the existing. So depending on which one it was, I think we've often had a 6 amp, just a little 6 amp breaker on the 3-phase, and the inrush beyond that, I think each one is about an amp per phase maximum. So you just need to size your fuses to that. There's a couple of very similar questions about is there any plan, and this is from Richard Kane, to support 2 different battery banks? So if you want to take that one, Lindsay.
Yeah, that's a good question, and thanks for that. It's something that we've talked a lot about effectively creating microgrids with multiple battery banks. I'll guess that's where your question is heading there. It's nothing in the immediate because we've had a good look at it, but we see some concerns with it. We do have already some systems installed where, let's say it's a bed and breakfast, just as an example, and there's a main house, and then there's 5 or 6 other houses. And what they've already done there is they've created an off-grid system for the main house, but then they put a separate system with other batteries down on the little huts or bed and breakfast outlets. Not the right word, outlets, but you know what I mean. But what they did is they actually put those in hybrid mode. The only thing we couldn't do was export from those systems because we don't have any means of actually controlling the output back into the off-grid system. It's certainly something we're mindful of doing, but we have done it to that degree already. But at the moment, we're not about to sort of drop out tomorrow a multi-battery type of system. No, because we like to use communications to do our control of PV, etc. We haven't got that nailed at this stage. So nothing in the immediate terms.
Yep. So the another question. So I'll answer Carl's question immediately. So yes, DC coupling can still be used with Powerchain, just in exactly the same way it has previously. Question from Paul Rodden: if you've got a relatively new 3-phase system, is it worth updating to the Powerchain configuration? Did you want to take that one, or will I, Lindsay?
Oh, you can take that one, and I'll just add a bit more to the DC coupling after you've done that one, mate.
Yeah. Oh, well, you do the DC coupling now.
Okay, I just wanted to add in that whilst we can do DC coupling and AC coupling, managed batteries cannot do DC coupling. So managed battery being one which has the CAN bus connection between the battery and the SP Pro, that's not approved for DC coupling. So again, BYD, LG Chems, Pylon Tech, Sonashine, I think they're the only managed batteries that we're working with at the moment. So they can't take DC coupling, but other than that, yes, everything else can take DC coupling.
Yeah. All right. And Paul Rodden, is it worth upgrading to the Powerchain configuration with the software? I would. And the reason I do that is everything is progressing with the Powerchain. We're migrating everything from the existing advanced multi-phase system through to Powerchain. And that just allows the onward compatibility with everything. Given you've said it's a relatively new system, I'm assuming that you don't have any CACO inverters on it. If you do, you won't be able to take it further forward. But otherwise, I wouldn't do it in a rush. But next time you're out there, you're going to service the system or something like that, part of your normal maintenance, I would be upgrading through to the Powerchain code, certainly.
And just a question there that I think you might have asked before, but Reed from Alice Springs, looks like the guys from Alice Springs, Reed and Paul Rodden, are busy, which is great to hear. Hope all is well in the centre there. Are we looking at doing anything such as communications back to the Pro using power line or wireless directional Wi-Fi? So we can do wireless connection between SP Pros and S-Cert inverters, Selectronic certified. So if it's a question, say, to the Fronius, the first Fronius can be wireless, subsequent Fronius must be wired. If you're using the ABB system, it can be wireless between all. If you're using the Select Sun grid inverters, that can be wireless between all as well. Question about Wi-Fi or over power lines. That's an interesting question. I've got my own views on it, but I think we probably just leave it at saying we're certainly mindful of trying to keep simplifying how you have to get communications and control of those inverters. But it's something we meet on almost every month and try and work out new ways of making things better, faster, and more appropriate. So thanks for your question, Reed.
Okay, so another question's just popped in. Is there an upper limit to the size of the external bypass contactor? I'm looking at bypassing 480 amps, and that's from Peter McKernan. There is an upper limit. It is 1,000 amps per phase, so 1000 per phase. So that fits well within your 480 amps, Peter, so no problem there.
Thank you, Ivan. So, well, that's a nice reply. Thank you, Peter. So we've got no more questions left. Now, if you want to ask a question other than Powerchain, we've got a couple of minutes left. We're certainly welcome to take those questions. We would be happy to take those questions. Daniel's asking, Daniel from Supply Partners, hope you're well, mate. Any plans to bring out an SP model without the contactor built in, as we know there'll be more systems that will require? That's a really good point, Dan. At this stage, there's no plans for that. One of the keys to keeping your costs down is making more and more of the same. It's a good question, though. I have to be honest, I don't think it's one that we've really talked about at this stage. Let's see how Powerchain goes. We hope it's going to be take over the world, of course, but nothing immediately, Dan, but certainly it's something we would have a look at once we've seen how Powerchain settles in. Cool. All right, then. Well, I think based on that, we can probably look to wrap it up. There will be a newsletter, I think, will come out next week, which will have a link to the recording of this webinar so that you can stop it and start it wherever you like, have a look at it when you need. What did they say there, etc.? So that will come out next week. Correct me if I'm wrong there, John, but I think that's coming out with the newsletter. So that will that should help. Really appreciate everyone making the time. I hope the time suited you. I know it's getting late for those in the eastern states, but it's still just coming into late afternoon for the western states. So really appreciate your input. Ivan, thank you for your technical expertise as usual, and John for bringing together this whole show. So hope you've enjoyed it. There will be a questionnaire will come out to you. Please answer that so that we know how to keep delivering the best service to you. We think that this method of technology is going to be the new norm for us with our training, but we'd love to hear any input that you've got. So I wish you all a good night. And is one last question. Could we have a mention of any newly released tech notes in the monthly newsletter? That's certainly something we'll be doing. Ivan has obviously been fairly busy with the Powerchain and doing the pre-release testing. And now that he's got that out of his way, that's certainly part of what he's very busy working on, bringing all that up to speed. Did you want to add anything to that, Ivan? Or
no, I was just going to say, yes, it's been quite a journey getting it all through, but with all the work we've put in, we think that Powerchain's really going to take off. But yeah, I'd also like to thank everyone for attending, and we look forward to helping you with your new Powerchain systems.
All right, good night. Thanks.
Good night, everyone. Bye-bye.